So in this segment, let us solve a few problems based on remainder theorem and factor theorem. The first question reads, using the remainder theorem, find the remainder when this polynomial is divided by x plus 2. So it is given that the polynomial is f of x equals x cube minus 2x square minus 5x plus 6. So what I'm going to do is I'm going to state the remainder and factor theorem over here. So the remainder theorem states that if f of x is divided by x minus a, then the remainder is f of a. So in this case, we have to use the remainder theorem because we are finding the remainder. So if this f of x is divided by, so if f of x is divided by x plus 2, then we can find the remainder. The remainder is going to be, I need to find the value of a. So again, we learned that there are two ways of finding the value of a. So either I equate the divisor to 0. So x plus 2 equal to 0 implies x is minus 2, which means that the value of a is minus 2. Or the other way of doing it is x plus 2 can be written as x minus of minus 2. That means the value of my a again is negative 2. So if f of x is divided by x plus 2, the remainder will be f of minus 2. So now f of x is given by x cube minus 2x square minus 5x plus 6. So f of minus 2 will therefore be minus 2 the whole cube minus 2 into minus 2 the whole square minus 5 into minus 2 plus 6, right? And this is going to be minus 8. Then minus 2 the whole square is positive 4. Positive 4 into negative 2 is again negative 8. And then I have positive 10, positive 6, which means this is negative 16 plus 16, which equals 0. So therefore, the remainder on dividing this polynomial by x plus 2 is 0. Now this is where the answer definitely ends. However, what I can do is I can make some conclusions based on the results that I have received so far. Okay. Of course, these conclusions will not be useful in this particular problem. But because we are solving problems based on factor theorem, I just wanted to make the conclusion. As f of minus 2 is 0, I can conclude that x plus 2 is a factor of the given polynomial, right? So therefore I can say that x plus 2 is a factor of f of x. Secondly, I can always confirm. Now over here they have explicitly mentioned that using the remainder theorem. However, I can confirm the same result by using the long division method. So in long division method, if I get the remainder as 0, I can conclude that it is a factor. And of course, the long division also gives me the remainder. So I can find the remainder using the long division technique as well. And long division technique also gives me the quotient. So this is how we applied the remainder theorem in this particular question. And let me pause for a couple of seconds and then we will continue. So let's move on to the next question. If the polynomials 2x cube plus ax square plus 3x minus 7 and x cube plus x square minus 2x plus a minus 2 leave the same remainder when divided by x minus 2, find the value of a. So I have two polynomials here. Let me assign the labels immediately. So let me say let f of x equals 2x cube plus ax square plus 3x minus 7, and let g of x be equal to x cube plus x square minus 2x plus a minus 2, right? These are the two polynomials. So if f of x is divided by x minus 2, then I know that the remainder is going to be f of 2, right? So this is again according to the remainder theorem. So I should explicitly state that. And how did I find the value of a? I equated the divisor to 0. So either I do x minus 2 is equal to 0, which means x is 2, or I compare x minus 2 with x minus a, and I notice that a is equal to 2, right? So now I can find the remainder, which is f of 2. And similarly, if g of x is also divided by x minus 2, then the remainder is going to be g of 2. So this is also again according to the remainder theorem. Now let's see what is given. It's given that both leave the same remainder, right? So leaving the same remainder means the f of 2 over here is equal to g of 2, right? Only then it would mean that the remainders are equal. That means I can find f of 2. Let me substitute 2 in place of x in f of x terms. So it is 2 multiplied by 2 cube plus a multiplied by 2 square plus 3 multiplied by 2 minus 7. This should be equal to g of 2. So how can I find g of 2? G of 2 would be 2 cube plus instead of x substitute 2. So 2 square minus 2 times 2 plus a minus 2. So let's evaluate this now. 2 cube is 8, 8 2s are 16, plus 2 square is 4, so this is 4a, and 3 2s are 6, 6 minus 7 is equal to 2 cube is 8 and 2 square is 4, 8 plus 4 is 12, minus 2 2s are 4 plus a minus 2. So you will notice that this is now a linear equation in A, which I can definitely solve. Let me combine the like terms. So I get 4a, 6 minus 7 is minus 1 and 16 minus 1 is 15. So 4a plus 15 is equal to a, 12 minus 4 is 8 and 8 minus 2 is 6. So I get 4a plus 15 is equal to a plus 6. So let us find the value of a now. So I can use the principles of linear equation. 4a plus 15 is equal to a plus 6, which means 4a minus a is equal to 6 minus 15, and therefore 3a is equal to negative 9, which means a is equal to negative 3, and hence the value of a is negative 3. Now they have asked me find the value of a. I think I found the value of a as negative 3, and they're asking me also find the remainder, right? So what I can now do is I can take my f of x and substitute the value of a in f of x. So let me do that right over here. Yeah, let's clear up some space. So to find the remainder, let me take I can either take f of x or g of x because both leave the same remainder according to the condition. So I choose to take f of x. So what is f of x? F of x is 2x cube. Then I have a is minus 3. So it's minus 3x square plus 3x minus 7. And I know that when I divide it by x minus 2, the remainder is going to be f of 2, which is 2 into 2 cube minus 3 into 2 square plus 3 into 2 minus 7. So that's going to be 16 minus 2 square is 4 3s are 12 plus 6 minus 7. And now let's find this value. So 16 minus 12 is 4 and 6 minus 7 is minus 1. And therefore the remainder is going to be 3, right? So in both cases, whether you use f of x or g of x, the value of the remainder will be 3. So this is how we solve this particular question. Let me again pause for a couple of seconds and then we continue with the next one. Okay, let's continue. Show that 2x plus 7 is a factor of the given polynomial and factorize the given expression. So this is a cubic polynomial. A cubic polynomial will have 3 factors, right? So the number of factors is always equal to the degree of the polynomial. So let me take this particular polynomial. I have to show that 2x plus 7 is a factor of this polynomial. So now there are 2 strategies to solving this question. One is I will just go ahead and do long division and I will get a remainder. If that remainder happens to be 0, then I can say that the divisor is a factor of the dividend. So let's try that technique first. So I have 2x cubed plus 5x squared negative 11x negative 14 divided by 2x plus 7. Let us now start the multiplication process. So 2x into x square, 2x into x square becomes 2x cubed and 7 into x square becomes 7x square. Now you again subtract. So I get 2x cubed minus 2x cubed cancels. 5x square minus 7x square is minus 2x square minus 11x minus 14. Now 2x into minus x, 2x into minus x is minus 2x square and 7 into minus x is minus 7x. Again, I'm going to go ahead and change the signs because I'm subtracting. So the minus 2x square term became plus 2x square and the minus 7x became plus 7x. So minus 11x plus 7x became minus 4x minus 14. Now 2x into minus 2 became minus 4x and 7 into negative 2 became negative 14, right? So now again I will have to invert the signs. So I have positive and positive term. Negative 4x plus 4x cancels. Negative 14 plus 14 cancels. So this becomes 0. Therefore, I can say that since the remainder is 0, I can say that 2x plus 7 is a factor of the given f of x, right? Now they have asked me to factorize, so I can say that the dividend, which is 2x cubed plus 5x squared negative 11x negative 14, can be written as divisor multiplied by the quotient, which is x square minus x square minus x minus 2, right? and 2x plus 7 is a factor. Now this is a quadratic polynomial. I definitely know how to factorize quadratic polynomials using the splitting the middle term method. So let me go ahead and factorize the given polynomial here. So I have x square minus x minus 2. I need to find two numbers whose product is 1 into minus 2, that's minus 2, and the sum is minus 1, right? So I know that these two numbers are negative 2 and positive 1. This gives me a product of negative 2 and sum of negative 1. Therefore, I can split the middle term as x square minus 2x plus x minus 2. X is common in the first two terms, so I get x minus 2, and 1 is common in the last two terms, so I get 1 into x minus 2, and therefore what I get is x minus 2 multiplied by x plus 1, right? So this is the factorized form of the given polynomial. So what I now get is this is 2x plus 7 multiplied by x minus 2 multiplied by x plus 1. And therefore, I can say that the factors of the given polynomial are, one factor is 2x plus 7, the other factor is x minus 2, and the third factor is x plus 1. So I can say that the factors of f of x are 2x plus 7, comma, x minus 2 and x plus 1, right? So if I were to find the factors, this is how I would express it. Whereas they have asked me to factorize the given expression, so I would leave the answer at this particular point, right? This is the factorized form of the expression 2x cubed plus 5x squared negative 11x negative 14. So here, because they did not mention whether I should use the remainder theorem and factor theorem, what I've done is I've just used long division and I've found out that it is indeed a factor, and of course the same problem can be also solved using the factor theorem. So let me pause for a couple of seconds for you to take a look at this, and then I'm going to solve the same problem using the factor theorem. Okay, so now let us see how to solve the same problem using the factor theorem. What I'm going to do is, I'm going to start off with using the remainder theorem. So let us assume that the polynomial now is f of x is equal to 2x cubed plus 5x squared negative 11x negative 14. Okay, this is the polynomial. And then according to the remainder theorem, so according to the remainder theorem, if f of x is divided by 2x plus 7, then the remainder will be, so let's equate this divisor to 0. So 2x plus 7 is 0 would imply that 2x is negative 7, which means x is negative 7 by 2. So this is f of negative 7 by 2. And to find f of negative 7 by 2, it would mean in place of x, substitute negative 7 by 2 plus 5 into negative 7 by 2 the whole square minus 11 into negative 7 by 2 negative 14. So this is 2 times negative 343 by 8 plus 5 into 49 by 4 plus 77 by 2 negative 14. So 2 and 8 simplify. 2 and 8 simplify to 4. So this is negative 343 by 4 plus 5 49s are 245 by 4 plus I can write this as 154 by 4 minus 14. Now why did I do this? Because I am going to take the LCM now. So if you simplify this, you have negative 343 plus 245, which is actually negative 98, and negative 98 plus 154 is going to be positive 56. So positive 56 by 4 is 14, and 14 minus 14 is 0. So if you actually evaluate this using all the LCM techniques and fraction techniques, then you get the answer as 0, and therefore I can say that because this is true, I can say that. So let's again create some space here, right? So I can say that since f of minus 7 by 2 is 0, I can say that 2x plus 7 is a factor of the given polynomial, which is f of x, right? And this is according to the factor theorem, right? This is according to the factor theorem. So this is how I prove that it is a factor. And again, if I want to factorize it, then of course I will have to perform this long division technique. And with long division, I get my quotient. And once I have my quotient, I can go ahead and factorize it, which is then very similar to the technique that was previously used. So the final answer would be this f of x. F of x is equal to 2x plus 7 is one factor, and multiplied by x square minus x minus 2. This is a trinomial which we know how to factorize. So it becomes 2x plus 7 times x minus 2 into x plus 1. This is the final answer. So here I use the factor theorem to show that it is a factor. And then I use the long division to find the other two factors. Okay, and that is how I solved this particular question. So again, let me pause for a couple of seconds before I move on to the next one. Okay, let us now move on to the next question. Show that x minus 1 is a factor of this particular polynomial, and then solve the equation x cubed minus 7x squared plus 14x minus 8 equals 0. So let's first solve the first part, which is show that x minus 1 is a factor. Now in this case, I'm going to use the factor theorem. So let my f of x be x cubed minus 7x squared plus 14x minus 8. Now if f of x is divided by x minus 1, then the remainder is given by f of 1, right? Now let's find the value of f of 1. So f of 1 is 1 cube minus 7 into 1 square plus 14 into 1 minus 8, which is 1 minus 7 plus 14 minus 8, which equals 0. And this is according to the remainder theorem, by the way. because we are just calculating the remainder. We do not know whether it is a factor or not. So that is why this is just the remainder theorem. Now, as f of 1 is equal to 0, I can conclude that x minus 1 is a factor. X minus 1 is a factor of f of x. And now this is according to the factor theorem, right? So factor theorem states that if f of a is 0, then x minus a is a factor of f of x. So this is the factor theorem. And now what I can do is, I have to solve this particular equation. So this is a cubic equation. This is a cubic equation because the degree is 3. So this is going to have 3 roots, right? And now we have to find those 3 roots. So if I can write this particular expression in the factorized form, then I can very easily find the roots. So to find all the factors, let me perform long division. So let's take x cube minus 7x square plus 14x minus 8, and let us now divide it by x minus 1, right? So now I'm going to divide it by x minus 1. So now let's write the quotient. So I have x into x square. So let me do one thing. Let me slightly shift this downwards so that I gain more space. Yeah. So now x into x square gives me x cube. So this is x cube, and minus 1 into x square is minus x square. Let us now subtract. So on subtraction, what I'm going to get is, when I subtract, it becomes negative and this becomes positive. X cube minus x cube is 0. Negative 7x square positive x square is negative 6x square plus 14x negative 8. Now x multiplied by minus 6x becomes minus 6x square, and minus 1 multiplied by 6x becomes positive 6x. Again, I have to shift the signs. So this becomes positive and this becomes negative. So negative 6x square positive 6x square is 0, and 14x minus 6x is 8x minus 8. And then x multiplied by 8 becomes 8x. So x multiplied by 8 is 8x, and negative 1 multiplied by 8 is negative 8. So now what you get is, again the signs will shift. So this becomes negative and this becomes positive. 8x minus 8x cancels, and negative 8 positive 8 is 0. So this is very much expected because x minus 1 is a factor, and that's why the remainder is expected to be a 0. So now if you notice, my f of x is, let's write it in the factorized form. F of x is the divisor multiplied by the quotient, that's x square minus 6x plus 8, and plus the remainder is 0. And that's why we don't write this part, because plus 0 adds no value. Now it's time to factorize this particular trinomial. So this is x minus 1 into, I need to find two numbers whose product is 8. Product is 8 and sum is negative 6, right? So the two numbers would be negative 4 and negative 2. And that's why I will split this as x square negative 4x negative 2x positive 8. So this becomes x minus 1 into, in the first two terms x is common, so it is x into x minus 4. In the last two terms minus 2 is common, it becomes x minus 4. And therefore I get this is x minus 1 into, in these two terms x minus 4 is common, so let's pull it out. So x minus 4 multiplied by x minus 2. So using the factor theorem, I was first able to conclude on one factor. Then I used the long division method to find the other two factors. And now they're telling me to solve the equation. So the equation that I am supposed to now solve is x cube minus 7x square plus 14x minus 8 is equal to 0. Now this particular term can be written in the factorized form as x minus 1 into x minus 4 into x minus 2 is equal to 0. So if product of three numbers is 0, then one of them has to be a 0, which means x minus 1 should be a 0, or x minus 4 should be a 0, or x minus 2 should be a 0, right? One of them has to be 0 if the product is supposed to be 0. And therefore, if x minus 1 is 0, x will be equal to 1. Or if x minus 4 is 0, x will be equal to 4. Or if x minus 2 is 0, x will be equal to 2, right? So the three solutions for x are, the solution set therefore can be written as 1, 2, 4, right? This is the solution set. So these are the values of x which satisfy the given cubic equation. So to summarize, we use the factor theorem to prove one factor. And after we use the factor theorem to prove a factor, we use the long division method to find the quotient. Using the quotient, we factorize the quotient and we found all the answers. And let me quickly box the conclusion points. We first use the factor theorem to conclude on the factor, right? This is the first thing that we did. Then we use the long division technique to find the quotient. And remainder was expected to be a 0 because x minus 1 was a factor. And then we used the factorization of trinomials to get the factorized form, right? That was the third checkpoint in this particular question. And then they were asking us to solve for the equation, which means they were asking us to find the values of x which satisfied this equation. So because product of three numbers was 0, one of them had to be a 0. And that is how we found the three values for x. So let me pause for a couple of minutes and then I will continue. Okay, moving on. Okay, let's continue with the next question now. Look, the polynomial x cube minus 2x square plus ax plus b has a factor of x plus 2 and it leaves a remainder of 9 when divided by x plus 1. We have to find the values of a and b. So it's given to me that x plus 2 is a factor. Let us write down all that is given and let's also conclude. Let us also conclude based on what all is given to us. It's given that f of x is equal to x cube minus 2x square plus ax plus b. It's given to me that x plus 2 is a factor. So x plus 2 is a factor. This would imply that f of minus 2 has to be 0, right? This is according to the factor theorem. Secondly, it is leaving a remainder of 9 when divided by x plus 1. It is also given that this f of x leaves a remainder of 9. So it is given that remainder is 9 when divided by x plus 1. So what this would imply is f of minus 1. So if I equate x plus 1 to 0, I get the value of a. So a is minus 1. F of minus 1 is equal to 9. This is according to the remainder theorem, right? Now if you notice, in my f of x there are two variables a and b. So if I want to find the two variables, I need two equations, right? And these are going to be my two equations. So first equation is f of minus 2 equals 0. So let us write that down. F of minus 2 is equal to 0. So let's substitute x as minus 2. So minus 2 the whole cube minus 2 into minus 2 the whole square plus a into minus 2 plus b should be equal to 0. Now minus 2 the whole cube is minus 8. Minus 2 the whole square is 4. 4 into minus 2 is minus 8. Minus 2a plus b equals 0, which means minus 2a plus b is equal to 16. This is the first equation. Now let's find the second equation. The second equation is f of minus 1 equals 9. So f of minus 1, let's make a partition here. So f of minus 1 is equal to 9. So let's substitute x as minus 1. So minus 1 the whole cube minus 2 into minus 1 the whole square plus a into minus 1 plus b is equal to 9. So minus 1 the whole square is positive 1. Negative 2 into positive 1 is negative 2. Minus a plus b is equal to 9, which means minus a plus b is equal to 9 plus 3, which is 12. This is my second equation. Now because you have two equations, you can now solve for a and b using the idea of simultaneous equations. So let us now take these two equations. Minus 2a plus b is equal to 16 and minus a plus b is equal to 12. Let us subtract now. So when I subtract, I have to invert the signs. So this becomes positive and this becomes negative. B minus b cancels. Negative 2a positive a is negative a is equal to 16 minus 12 is 4, which implies a is negative 4. And now using a equals negative 4, I can find the value of b. So substitute a equal to negative 4 in, say, the second equation. I think that's a better one. We get negative of negative 4 plus b is equal to 12, which implies b is equal to 8. So I got the values of a and b, which means I can now rewrite my given polynomial. The given polynomial is therefore f of x equals x cube minus 2x square. A is negative 4, so negative 4x, and b is positive 8, so plus 8. And this is the required polynomial. Now I have found the values of a and b, so I have completed the first part. Now they are asking me to factorize the given expression. So what I am now going to do is I am going to use the long division method. I know one of the factors. One of the factors is x plus 2. So I will divide this by x plus 2 and then I will find the other factors. So I need some space on the board to do it. So let me pause for a few seconds. Take a look at what is done over here and then I will proceed with long division. Okay, so now let's perform long division on this particular polynomial to factorize the given expression. So let me make some space. So to find the other factors, let us take the polynomial, which is x cube minus 2x square negative 4x positive 8 and divided by x plus 2, right? Divided by x plus 2. So x into x square gives me x cube. So x into x square is x cube and 2 into x square is 2x square. Let us now subtract. So when I subtract, I know that x cube minus x cube cancels. Negative 2x square becomes negative 4x square. Negative 4x plus 8. Now let me find the right quotient. So x into minus 4x will give me minus 4x square and 2 into minus 4x will give me minus 8x. Let us now again subtract. So when I subtract, the sign of 4x square becomes positive and this also becomes positive. Negative 4x square positive 4x square becomes 0 and negative 4x positive 8x is positive 4x plus 8 and x multiplied by 4 becomes 4x and 2 multiplied by 4 becomes 8. So the remainder is 0, which is expected, by the way, because x plus 2 is a factor. And therefore, I can say that f of x is equal to the divisor, which is x plus 2 multiplied by the quotient x square minus 4x plus 4. And now this is a trinomial. I can go ahead and factorize it. So if I factorize it, it becomes x minus 2 the whole square, right? So we know how to factorize a trinomial. Take the product and sum and then factorize it using splitting the middle term method, right? So this helps you factorize the given expression. And therefore, f of x can also be written as x plus 2 multiplied by x minus 2 the whole square. This is the factorized form. So let me again wait for a couple of seconds for you to grasp what was done on the board and then we will continue. It was a pretty long problem, by the way, using the given conditions that x plus 2 was a factor and that the remainder was 9 when divided by x plus 1. We first found values of a and b and then using those values of a and b, we went for long division. We didn't choose x plus 1 because x plus 1 is not a factor, but x minus 2 was a factor. So we divided the polynomial by x plus 2 and then we found the quotient and then we factorized the quotient. So a pretty long one, but a very interesting problem. Okay, moving on to the next question. In this question, it is given that x minus 2 and x plus 3 are both factors of the given polynomial. Find the values of a and b. So let's assign a label for the given polynomial. Let f of x be equal to x cube plus ax square plus bx minus 12. What I've done is I've arranged the polynomial in the standard form where the powers of x are in the decreasing order. It's given that x minus 2 is a factor. So x minus 2 is a factor, which implies f of 2 should be equal to 0. So which theorem states this? The factor theorem states this. And then it is also given that x plus 3 is a factor. So if x plus 3 is a factor, I can again conclude that f of minus 3 should also be equal to 0. This is again according to the factor theorem, right? So let's now take the two equations. Again, we have two variables here, so we need two equations. So f of 2 is equal to 0 would imply 2 cube plus a into 2 square plus b into 2 minus 12 is equal to 0, which means 8 plus 4a plus 2b minus 12 is equal to 0, which means 4a plus 2b is equal to 4, and dividing the equation throughout by 2, you get 2a plus b is equal to 2. So this is my first equation. Now let's take a look at the second condition that we have. We have f of minus 3 equal to 0. So f of minus 3 equal to 0 means we have minus 3 the whole cube, then plus a into minus 3 the whole square, plus b into minus 3 minus 12 equal to 0. So this would mean minus 27 plus minus 3 square is 9. So this is plus 9a minus 3b minus 12 equal to 0, which means 9a minus 3b minus 27 minus 12 is minus 39 equal to 0. Dividing throughout by 3, I get 3a minus b is equal to 13. So this is my second equation now. I know that I can solve for a and b using simultaneous equations. So let's write both the equations. We have the two equations that we have are 3a minus b is equal to 13 and 2a plus b is equal to 2. So if I add the two equations, I get 5a is equal to 15, which means a is equal to 3. Now let's substitute a as 3. Substitute. Let's mark these equations 1 and 2. So substitute a equal to 3 in, say, the second equation. What I get is 3 multiplied by 3. We are substituting a as 3. So 3 multiplied by 3 minus a is equal to 13, which means 9 minus a is equal to 13, which means negative a is 4, and this implies a is equal to negative 4. So the values of a and b are therefore obtained. Again, just to recap, we were given two factors. So using the factor theorem, we were able to build the two equations. And once we built the two equations, we then started equating. We can start using the concept of simultaneous equations to find the values of a and b. So this was the approach in solving this question, and I will pause for a few seconds and then we will continue with the next. Okay, let us now continue with the next question. Using factor theorem, factorize x cube plus x square minus 4x minus 4. Now over here, they have not given me a single factor, right? Nothing is given to me. So what I will do is, I will use the factor theorem to great advantage over here. Let's consider that f of x equals x cube plus x square negative 4x negative 4. Now I'm going to use the trial and error method. So what I mean by that is, let's find f of 0. So f of 0 is 0 cube plus 0 square negative 4 into 0, negative 4, which is equal to negative 4 by the way, right? And since f of 0 is not equal to 0, we cannot conclude anything. Now let's take f of 1. So f of 1 is 1 cube plus 1 square, negative 4 into 1, negative 4, which is again not equal to 0, right? And therefore, because it's not equal to 0, I can say that this implies x minus 1 is not a factor, right? So now I'm trying to find that particular number which gives the value of this polynomial equal to 0. So now let me find f of minus 1. Let's substitute and see what I get. I have negative 1 the whole cube plus negative 1 the whole square minus 4 into negative 1, negative 4. So this becomes negative 1 the whole cube becomes negative 1. Negative 1 the whole square becomes positive 1. Negative 4 into negative 1 becomes positive 4, and then I have negative 4, and this equals 0. So now, as f of minus 1 is equal to 0, I can say that x minus of minus 1 is a factor, or in other words, I can say that x plus 1 is a factor, right? So using the trial and error method, I started substituting different values of x, and that particular value of x where I got a 0 as the value of the polynomial, I got the first factor. Now this is according to the factor theorem. Now because I have one particular factor, this is a cubic polynomial. So cubic polynomial will have 3 factors, of which x plus 1 is one factor. So again, let's perform long division to get the other 2 factors. So minus 4x minus 4. Let's divide this whole thing by x plus 1, right? Now let's find the quotient. So x into x square. So x into x square gives me x cube, and 1 into x square gives me x square, and then I subtract. So when I subtract, x cube minus x cube cancels, x square minus x square also cancels. So I get minus 4x minus 4, and then x multiplied by minus 4 gives me minus 4x, and 1 multiplied by minus 4 gives me minus 4. Again, when I subtract, I have to flip the signs, and therefore my remainder is 0, which is expected because x plus 1 is a factor. Therefore, my f of x can be written as x plus 1, that's the divisor, multiplied by the quotient, which is x square minus 4. Now, I will observe that x square minus 4 is of the form x square minus 2 square, which is a plus b multiplied by a minus b, and therefore I can write this as x plus 1 into x plus 2 multiplied by x minus 2. And therefore, I have already factorized f of x. The factorized form, so let us write that as an answer over here. The factorized form is x plus 1 into x plus 2 into x minus 2. And now they are asking me to solve this particular equation. So let's go ahead and solve this equation. Let's see how to solve it. If you think about it, we can bring all the terms to the left side. So the equation that I get is x cube plus x square minus 4x minus 4 is equal to 0. And wait, I just factorized this polynomial right now, which is x plus 1 into x plus 2 into x minus 2 is equal to 0. Now because the product of the 3 terms is 0, one of them has to be 0, which means either x plus 1 should be 0, right? So the 3 options that I have are either x plus 1 should be 0, right? Let's note that down here. So either x plus 1 is 0, or I have x plus 2 is 0, or I have x minus 2 is 0. Because if product of 3 numbers is 0, one of them has to be a 0, which means x can be either negative 1 because shifting the 1 to the other side, or x can be negative 2, or it can be positive 2. And therefore, the solutions for x are -1, -2, +2. So these are the values of x that satisfy this particular equation. So let me pause for a couple of seconds. We have finished solving about 8 problems in this session, 8 or 7 problems maybe. And we conclude this particular session. We will solve more problems in the next session.